passions as well. So I've taught hundreds of students over these years, and transformed them from various phases into a career in the DevOps and cloud space. So I'm definitely excited to coach all of you guys again. This will be like a journey for the next 3 to 4 weeks. A portion of the training will also be done by like a different trainer, but we'll together we'll cover the whole course. So that's a little bit about myself. So like let's get into the details. So most of you guys would have some opinion or idea about what DevOps is. Like, can anyone tell me what is your understanding of DevOps is?
Krishna, this is Malvika here.
Yeah.
Uh, According to me, DevOps is a practice that actually brings developers, operator, testers, and their activities together in a
Mhm.
collaborative fusion using proper process and technique to achieve fastest and high quality releases, software releases.
Very good. Great answer, Malika. So one funny thing about DevOps is that DevOps is perceived by different people in different ways. Actually, so you as a DevOps engineer is giving this answer. For example, a full stack Java developer like Divya, she might have a different opinion about DevOps. Like Divya, what is your understanding about DevOps? Like as a full stack Java developer, what is your interaction with the DevOps team in your company?
Yeah, it's like they'll manage all the applications. Uh, I mean, they'll see like all the build releases,
Mm-hmm.
um, and then they'll make sure that everything like they'll see like most of the installs. Mm, I mean, like Jenkins pipeline and stuff.
Mm-hmm. Mm-hmm. Okay. Yeah, that's cool. So if you look at Divya's answer is more from a person who writes code all day and who delivers the code. And once her code is checked in, she's moving on to her next coding task. So she wouldn't have like the top level view of what happens end to end after the code she wrote is checked in. So that's one way, one perspective about DevOps that people might have. So why don't we ask Vishal, who has like a decade of software engineering experience? He worked in the middleware aspect of software engineering. So Vishal, what do you think DevOps is? Like in your understanding and perspective, how have you interacted with DevOps teams in your company?
Look at you.
So, from my perspective, I'm still interacting individually with the different teams, okay, development, build, and release. But the knowledge I have on it is the team who interacts closely with multiple teams to deliver the software. So that is where everything is driving towards. So
Mm-hmm.
so far I was still part of individual teams where we haven't went into that kind of area yet.
Mm-hmm. Mm-hmm. Yeah. That's cool. Awesome. Awesome. Yeah, yeah. So yeah, I mean, my answer about what DevOps is will not be anything too different to all the several answers that these people give. I'm not gonna give an entirely two different answer. Pretty much, if you piece together all the three different answers together, that's pretty much what DevOps is. So like DevOps is basically like a software engineering discipline. So like there's like Java programming is a software discipline. QA is a software discipline. Like just like that, DevOps is also a software discipline. And in this software discipline, what we are doing is we are automating the release process of software applications, making software releases fast by eliminating manual activities. And by introducing more and more automation, we are also making software releases more repeatable. And CI/CD, continuous integration and continuous delivery, is also an important aspect of DevOps, what DevOps is. So by implementing CI/CD, stuff like that, we are integrating all the software tools that are involved in certifying the quality of a software build. And we are making the software releases more reliable. Software releases become more reliable because all forms of testing, static code analysis, security scanning for vulnerability analysis of your code, unit testing, automated testing, stress testing or load testing, all these different testings is done for each and every code build, each and every new piece of code that is written for your application, because the DevOps engineer in your team, they have created like a pipeline that integrates all these tools, and each and every code change goes through all these different types of testing. And towards the end, you are able to look at the test results, unit testing results, automated testing results, load test results, and then your static code analysis to know how much is your code quality, how much is your code coverage, how much is your test coverage, stuff like that. So because you have all these reports at your disposal, you are now able to assess the quality of your build and the reliability of your code, even before your code reaches to production. So a software engineering discipline that provides a software company with all these things, that is called as DevOps. So do you guys have any questions? I mean, please keep the class very interactive. Always please feel free to stop me and ask me questions, stuff like that if needed. So like one more thing, this slide is basically like is talking about why DevOps. Like there's a company called as X, or a big company like Google, or they're a small company, some startup in San Francisco. Why should they think about DevOps? Like what is the business value, that DevOps provides to a company? So these are some of the top three delivery challenges that small, mid, or big size companies suffer. So one thing is, if there is no DevOps in the company, there will be a lot of manual activity. In order to release a software application, a person might be logging into server, executing commands or scripts, and there will be like a sequence of actions that need to happen. One person does this, then another person does another thing, then only another person can do something. Like this, it can be a lot of manual activity. And this manual activity will be error prone, stuff like that. So DevOps provides you release and deployment automation. Okay. Next is coordination. Suppose you are working in a big company like Google. So Google has so many different products. One Google product uses another Google product to fully run and provide functionality. One application can need 2 or 3 other applications. This application can have dependencies, meaning that if 2 or 3 other applications are working correctly, then only this application will work correctly. So like this, in big companies where there are like different groups of software engineers writing different applications, coordination of these software changes become difficult. Like, for example, I'm writing one application that needs an API that should that needs an API, and my application is going to make an API call in a specific format, including specific set of information, and the other team is going to send me API response in a specific format. And without telling me, if the other team changes the fields or what type of data is included in the API response, and now I make an API call to that application, I'm unable to understand, my API is unable to understand the response from the other API, and my API functionality, my application functionality is broken because the other person has changed their code without really notifying me. In big companies, stuff like that, these kinds of things keep on happening. That is why we have like a release manager, a release management team, to untangle the dependencies between software projects, making sure the risk of new software being introduced to production is reduced. So all these kinds of delivery challenges, software delivery challenges, are like, addressed by DevOps. Okay, another important thing is Agile. So like Agile software development is something that every company wants to implement these days, In Agile, what's happening is like, Agile software development, I'll take a separate class on this, but long story short, what Agile software development does is like, Agile prescribes a software company to release more code to more code to production, in short durations of time. Like previously, what used to happen is like 10 years ago, yeah, companies used to release new versions of software like say every 6 months, or once every 6 months, or once every year. Like that, they used to release a software, and that software will have like 10, 15, 20 different features. It will be like major upgrade from old software. But what Agile tells you to do is, instead of releasing 10 features after 1 year, why don't you release one feature per month to production? You release a feature, try to get feedback from from your users, if the feature you released is something they like or not, and then iterate over customer feedback, customer requirements, stuff like that, rather than doing one big bang release. Do a lot of small releases. So what this means is that, previously, if it takes like 2 or 3 days to release new code to production, and it used to happen only once every 6 months or 1 year, it used to be okay. But if you have to spend 3 to 5 days to release code to production every 1 month, then it's going to become a huge overhead to the software development teams, the delivery teams. So that is why we need DevOps and automation. So long story short, in order for a company to be truly agile, in order for a company to truly implement agile software development, you know, that company needs to have a good DevOps team and good DevOps processes and tools in place. For achieving agile, you need DevOps. Understand? Are you guys following?
Yeah.
Good. So, like, DevOps is basically becoming a demand, very much in demand due to the advent of new tools and technologies also. Like, there's a increased use of data center automation and configuration management tools. Like, there are new tools like Puppet, Chef, Ansible, stuff like that, using which you can automate the configuration of all of your servers in your data center. That is one trend that is causing a lot of demand for DevOps. There's also like, cloud infrastructure is becoming widely available, So you can easily spin up in the infrastructure in public clouds like AWS, Azure, Google Cloud, stuff like that. And all the companies want to use cloud infrastructure. That's also one more important trend that is fueling DevOps. And all companies want to become truly agile. They want to use agile software development processes and methodologies. That is also fueling the need to have a DevOps team and hiring DevOps engineers. So also like, the mission of companies to deliver better quality software product with a lesser number of issues in a faster amount of time. All these kinds of various factors are what fueling the investment into a DevOps team by companies. So like basically dev and ops, right? There are two portions of it. They're like the developers should work closely with the operations team, and the operations team should work closely with the developers. The ops people should have more inputs and understanding about the technology stack, the various libraries used, and the dependencies of a given application, and who uses a specific application. They need to have a holistic picture about the technology stack. And the developers also need to know the platform on top of which their application is running, and what type of servers are used, what type of runtime is used to run their application, stuff like that, so that they can write cleaner, secure, more robust applications. Keeping this knowledge in the background. So that is why DevOps is two different software groups coming together and making the magic happen. Okay. So this diagram, it's basically like talking about Agile and DevOps and what each does. So basically in Agile, basically what Agile is doing is like bridging the gap between what customers want and the requirements with which the development and test teams are working on. The companies need to build products that customers love, and they need to have a feedback loop so that instead of getting feedback after a long period of time, they should get regular feedback from customers on their changing needs, and the company should continue to build products that the customers need then and there, not after 6 months or 1 year, that kind of a thing. So like agile methodology prescribes designing, building, testing, reprioritizing the source scope of software that's built, and then for the updated scope, again design, build, and test new software, new iterations of software. So that is what Agile is all about. In order to make this happen, like design, build, and test fastly, you need DevOps. In DevOps, somebody checks in code, automatically the code gets deployed into the various environments. And in each application environment, different types of testing happens. And, you are able to continuously deploy new code, test the code if the code is working as expected or not, stuff like that. So that's the relationship between Agile and DevOps. In order for a company to achieve Agile, it needs to have a proper DevOps tools and processes in place. Are you guys following up to here?
Yeah.
Yes.
Okay.
Yes.
Good. So this is just another slide that is talking about continuous integration being extended as continuous delivery, stuff like that. So I'm gonna teach you guys these terms in the coming slides. So what is continuous integration? Suppose we have Divya in our class. She's a full stack Java developer. Her boss assigns her a coding task, and she thinks that she has finished. She modifies the code and pushes it to the Git repository of her application. Now she thinks that the new code that she wrote is exactly doing what her boss wanted the code to do, you know, that kind of thing. But she is just thinking. She does not know for sure if the new code that she has just checked in, is it working as expected or not? Is the new code that she just checked in, is it compiling? Is it passing the unit tests? You know, after she checked in the code, are we able to generate the application build, like the war file or the year file of your application after the latest code modifications made by her? Are we still able to generate the war file, create the build or not? You know, there is nothing in, she does not know anything. She just checked in the code. So the DevOps engineer in the team, they are going to like use a continuous integration tool. And like typically most of the companies, they have Jenkins. And Jenkins is just like a software. So whenever, you know, somebody checks in new piece of code in the company, this software gets notified. And this software, what it does is it's going to take the latest code, run the commands or scripts, which will compile the code, create the software package, and then you know, it is going to provide instant feedback to the developer. Like within 30 seconds or 1 minute of checking in code, Divya is going to get like a Skype message or a Slack notification or an email from the Jenkins application or the CI tool saying like, okay, your new code looks good, or even your new code looks bad, you know, stuff like that. So the process of getting feedback, the process of getting instant feedback, whether the newest code that they checked in is good or bad, that is called as continuous integration. Okay. So what is continuous delivery? You know, this is another definition that I'm going to talk about. So what is continuous delivery? If you take any application, right, any software application in the company, it is going to be deployed in various environments. Okay. So there might be like a dev environment, you know, what is a dev environment? It is just it is just a collection of servers inside your firewall, inside your data center, and nobody else is going to use those servers for any other purpose. And you know, the dev team is going to use these set of servers to deploy the latest code of that application on these servers and making sure their application is working. For example, Divya wrote her latest code, but you know, she needs to deploy her application somewhere and then go to the URL of the application and check if the new code is doing what she wanted it to do or not. She needs to have a place to verify the functionality of the new code that she wrote, right? So, you know, like in companies, you have like a dev environment. The dev environment is mostly operated by the developers dedicated for that software project, not anyone else. And they're just going to deploy the latest code onto the dev environment and check if the developer themselves are able to check if the code looks good or bad, or if he has to fix any bugs in his code, you know, things like that. And then you typically have like an integration or a QA environment next. In the integration or QA environment, what is happening is like there might be like a dedicated QA team. The QA team might be writing automated tests in Cucumber, Selenium, or writing SOAP UI based web services tests, or you know, it might be just a team of manual testers. You know, it can be anything. So they are going to have a set of dedicated servers, which is not used by anybody else, and they are just going to use that environment and use those set of servers called as a QA environment. And they, whenever developer wants them to certify a new build, they ask the DevOps engineer to deploy the requested build into the QA environment. And in that QA environment, they are going to do their testing and provide feedback, like, you know, hey, this build looks good, or this build looks bad. You know, stuff like that. And then these functions are not working, so I'm going to create these bugs that you need to fix. Or, they're just going to come back and say, okay, the developers did a good job. All the requirements that are, if the application is meeting all the requirements given to us. Like that, for that, we can use like a QA environment. And you can also have a stage environment, stage or a pre-production environment where, you do like final testing, or you have like executives or business analysts, those kinds of people finally certify the build if it's good quality or not. And then, even if things are working as expected in the stage or pre-production environment, then people push the code to production environment. And when the code gets pushed to production environment, that's when people like us or the end users or customers can start using the latest code that is developed by that company. So if you take any application, right, the code is getting deployed in multiple environments: dev, QA, stage, prod, stuff like that. So the process of automating the code promotion process from dev all the way to production environment of the application, that is called as continuous delivery. Okay. So that's also like in Google, stuff like that, we also use another term called as continuous deployments. What is continuous deployment means? Like you have fully automated CI/CD pipelines for your application, and instead of deploying code like once a month or once every 2 weeks, you deploy code to production 5 or 6 times in a day. In a single day, in production, the code will be redeployed at least 5 to 6 different times. So big companies like Facebook, Google, Microsoft, or LinkedIn, they follow the process of continuous deployments. So that is another definition that you typically hear. Okay, so here in the current slide, I'm talking about two new definitions: continuous testing and continuous monitoring. Okay, so what is continuous testing? So like the process of iterating over new versions of software code, and being able to certify your new code through various forms of testing in an automated fashion. That is called as continuous testing. Like, you want to run your unit tests, you want to run automated tests, you want to do manual testing, you want to do all these kinds of testing, but it needs to be in a streamlined and automated way. So the process of automating the various forms of testing that's available for a given application, like executing the tests is what I'm talking about. The automation to execute the various forms of tests that are written for a given application, that is called as continuous testing. Okay, what is continuous monitoring? Like all these big companies, for example, you take google.com or facebook.com, it cannot be down even for a single second in an entire year. That application cannot go down. So it should always be highly available. So for an application to be highly available at all times, 24/7, 365 days time, somebody needs to set up the monitoring and alerting tools. If the servers running the google.com application or facebook.com application, if they crash, and the DevOps engineer at Facebook or Google, they come to know lately, then facebook.com or google.com will be down until the DevOps engineer realizes that a mistake happened on the company servers, and he remedies the mistake that happened on the servers, stuff like that. The applications will be down. So the process of configuring alerting tools, notification tools, application logging tools, stuff like that, to make sure a given application is continuously running at all times in production, that is called as continuous monitoring. Are you guys following all the definitions that I'm throwing at you?
Yes.
Yeah.
Okay, good. So few more definitions I'm going to teach today. Okay. So the next definition is a software build. So like what is happening is like, you know, in companies you have like software version control systems. Like you have like a GitHub or a GitLab or a Bitbucket. You have like Git-based version control systems. You know, if a company has different software projects, each and every software project has a dedicated GitHub code repository. Okay. And inside the code repositories, you have all these files, your JSP files, your Java files, your HTML files, any other infrastructure code, Docker files, you know, everything will be there. You know, all the code that is dedicated for a given software project, it will be located in a single code repository in GitHub. Now, you know, if you take like a web server or an application server like JBoss or Tomcat or Apache or Nginx, you know, all these like, you know, web servers and application servers, they do not have they do not understand the content of Java file or JSP file, you know. So the Java code has to be compiled into classes, you know, and it needs to be packaged as a jar file or a war file. You know, the web servers and application servers, they understand those things only, jar file, war file, or year file. Okay, they do not understand .java or text files. So how do you like take the raw source code, convert the raw source code into a jar file, a war file, or a year file, which a application or a web server can understand and run inside it, run inside the JVM. So the process, like for that, you know, we have special tools. We have special tools called as build tools. And these build tools are like, you know, Maven, Gradle, you know, and, you know, these tools, they are going to like convert the raw source code into application builds. Okay. So the process of converting, you know, the raw source code into a jar file, war file, or a year file, which the application server understands, that is called as the process of doing builds. You know, the process of a build is a executable artifact. Okay. So like, and we are converting the Java code into like a war file or a year file using build tools like Maven or Gradle. Okay, what is a deployment? So now you used it to build tool like Maven or Gradle, and you transformed the source code into an application artifact. Now somebody like needs to take this application artifact, put it inside a web container. Like you guys would have heard the name JVM, Java Virtual Machine. So Java Virtual Machine is nothing but a running container. And inside the container, if you put like a application artifact, like a build, it is going to open up the build and run all the class files, load all the class files inside your application build, and make the entire software application available for your customers. So that is called as the process of taking a build and putting it inside a web server or and running it inside a web server or an application server. That is called as a deployment. So two new definitions I teached: a build and a deployment. Are you guys able to follow?
Yeah.
Okay. Okay. So that's one aspect of it. So the next concept that I'm trying to teach is like, do not worry too much about the code here. I'll teach you when the time comes, I'll teach you how to write that code. But generally understand two things. Today's in the modern day, everything is being done as code. All infrastructure is being done as code. the process of creating, maintaining, and destroying infrastructure can be done programmatically. Like, um, like Java developers, what they do, they have like frameworks. They use like SDKs, software development kits, and using the libraries, using the inbuilt libraries and functionality provided by the software development kit, they're writing application programs. The same way, all these clouds like AWS, Google Cloud, Azure, they have software development kits in different languages like Java, Ruby, Python, stuff like that. So the DevOps engineer needs to know a little bit of programming. Do not think that there is no coding in DevOps. There is definitely coding in DevOps, because we, as a DevOps engineer, we are automating the release process of software applications. So like, the DevOps engineer needs to learn how to use the SDKs provided by the cloud providers. And then he's going to write a code. If you want to create a new virtual machine, just make an API call. If you want to get like a new load balancer, make an API call. If you want a database for your application, make an API call. You want to update the DNS records of your application, make an API call. You want to close down a firewall or open a port on a server, or open a port in a specific network. All of these things are just API calls. So you import the SDK of your cloud and then go through the documentation, your SDK documentation, and use valid libraries to make API calls. And programmatically, you are able to do each and everything related to infrastructure. So that is one aspect of infrastructure as code automation that DevOps engineers are expected to do today. Infrastructure provisioning, ongoing reconfiguration of infrastructure, and destroying any unused or unwanted infrastructure, everything is done programmatically. And one more thing is configuration management tools. Like, if we have configuration management tools like, AWS, like Chef, Puppet, or Ansible, using which we can do configuration management. Like, what is configuration management means? Somehow, using some method, you already created infrastructure. For example, you have 100 servers. On all of with your 100 servers, you have Java version 8 installed. Now your company is writing new applications, and you want to, your developers wanted you to install, configure, and configure Java version 10 on each and every company server. Now, like you do not need 100 new servers, but you need to upgrade the Java version on all the 100 servers. So for those kinds of automation, we can use tools like Chef, Puppet, or Ansible and write code. And when you execute this code, Java gets upgraded from 8 to 10 on all the 100 servers. You just write 4 lines of code. That 4 lines of code will be so powerful that it configures all the 100 servers in a single shot. Like that, we can use these tools and achieve configuration management. So it is this kind of automation also where most of you will be getting jobs. So the jobs that you get, the DevOps jobs that you get today is mostly about doing this type of automation. Okay, so like if you look at this diagram at the bottom, so like the process of providing feedback to instant feedback to developers about the new code that they checked in is good or bad. That is called as continuous integration. Okay, the new code is looking good. It's working. You are able to, it's compiling, you are able to create the application package, and it is passing unit tests. Now you are going to use continuous delivery to automate the process of deploying the new build into the dev, test stage, and prod environments of the application. And in each environment, you are automating the various forms of testing that needs to happen in that environment. So that is called as continuous testing. And once your application reaches production, you're continuously monitoring your infrastructure and making sure your application is highly available at all times. That is called as continuous monitoring. Are you guys following everything? Am I going too fast?
No.
No, it's fine.
Okay, good, good. So one more thing, I'll touch this topic a little later. So as a homework, why don't you guys Google each and every software tool in this slide and learn what that tool does, just learn what is Jenkins, what is Puppet, what is Docker, where it is used, things like that. Just be curious and learn about it. Okay, so like I'll come back to this later, and okay, so one more thing, like we talked about different tools. We already covered a lot of different definitions in DevOps, stuff like that in the previous slides. So let's talk about the key technical capabilities a DevOps engineer need to have. So a DevOps engineer need to have very good knowledge about the version control systems like Git, GitHub, Artifactory, Nexus. They need to know what each tool is all about, and how to use those tools, and how to connect all these tools together, and make sure all the software code related to various software applications are in a single location. All the application builds related to a specific software application is located in a single location. All that sort of stuff. How do we do branching? How do we do merging? How do we name the application builds? How do we name the software releases? The DevOps engineer has to take care of all of this. And another term that you typically hear is software configuration management. Software configuration management means like branching, merging, application build naming, release naming conventions, all these kinds of things is called as a software configuration management, SCM. So they need to be good. They need to have advanced to expert level knowledge on these kinds of tools. Okay. A DevOps engineer should also be good in automation or unscripting. Okay. So like, they need to have good programming skills, like in Python, shell scripting, PowerShell, Linux operating system. They need to have good knowledge in these kinds of areas. So one thing to keep in mind is that, if you take application programmers like Java programmer, .NET programmer, or even for that matter, Python programmer, they will be using different web frameworks, writing MVC or using the MVC design patterns, writing heavily object-oriented code. They might be using different frameworks, different libraries like Spring, Hibernate, Spring Boot, all these kinds of things, Django or Flask, all these kinds of frameworks, and writing very complex object-oriented code. As DevOps engineers, we do not need to know all that. As DevOps engineers, we just do scripting. Scripting means, you need to learn how to use different loops, like if loop, for loop, and you should learn how to use different data structures, like how do you read and write data into a array, or use a hash map, or that kind of stuff only. Most of the time, we're going to write like up to 50 lines of code. That's it. But again, still, you need to do programming and automation and scripting. So when I say DevOps engineer should be good in automation and scripting, it is that level of knowledge, programming knowledge, that you need to have. Okay, one of another key capability of DevOps engineer is to like how to understand, how to write the code necessary for Maven, for build tools like Maven, Gradle, stuff like that. you know and DevOps engineers should also have pretty good experience with CI/CD tools like Jenkins, TeamCity, stuff like that. They should have pretty good experience with application and web servers and doing deployment automation. How do you automate the process of taking a WAR file and deploying it in Tomcat programmatically? So they should also have pretty good knowledge with infrastructure provisioning tools. Provisioning means creation. How do you create brand new servers, load balancers, storage, create networks? How do you do all that stuff? That is called as provisioning. Once the servers are created, in an ongoing fashion, doing maintenance and reconfiguring infrastructure as needed, that is called as configuration management. So they need to know how to do all that sort of stuff. And many of the DevOps jobs also involve production support, like our environment support, meaning that, if you have a specific application running on hundreds of servers, you need to make sure that all these hundreds of servers are in a good state and the application is running in an optimal fashion on all these servers. So, and from time to time, if there are issues with your application, you should be able to debug why your application is not working properly. And is it a server configuration issue or an environment issue, or is it like application code issue? We have to tail the application logs, server logs, and look for error messages or stack traces, read and understand that error message, and based on that, you are able to debug, why your application is not working correctly, stuff like that. This kind of production support or environment support can also be one of your job duties, typically. So these are some of the key technical capabilities a DevOps engineer need to have. So far, any doubts? Are you guys following me? Any doubts so far? Okay, are you guys able to understand everything?
We are good, Krishna.
Yeah.
Okay, yeah, good. So next, variants of continuous delivery are just thing, right? So suppose you can have certain applications, certain companies where you don't even have any cloud. Everything is like you take physical servers and install operating system on the physical servers, then you run your applications on the operating system. Or you have like virtualized environments, like you use tools like VMware's ESXi or vCenter, things like that. You use VMware software. You take physical servers, install and configure VMware on it, and through VMware you create virtual machines on your physical server and connect to those virtual machines, deploy your application on your VM, and point DNS to the applications running on your VM and serve your customers. So there is no cloud. It's purely on-prem. Like there are so many companies like that. In those companies also, you have like continuous integration, delivery, continuous testing and monitoring, stuff like that. So continuous integration, continuous testing, or continuous delivery, all these things are happening in data center servers that are either physical servers or virtual servers, but VMs. Okay. So that is one way that companies are doing, infrastructure. Another thing is cloud or hybrid. Like you have certain applications running in the public cloud like AWS or Google Cloud or Azure, and you have certain applications running in the data center. And apps in the cloud will talk to data center apps will talk to cloud, and you are implementing continuous integration, delivery, stuff like that also. So there are like a lot of companies that are in this kind of a state. Okay. And you also have polycloud, meaning like if you are working in a very large environment, in a very large company, for example, Walmart, if you take Walmart or Macy's, they have a little bit of AWS, they have a little bit of OpenStack, they have a little bit of, different, things. So you can have like more than one cloud in the same company also. That is a polycloud scenario. And DevOps engineer might need to do automation. Like for the polycloud environment, you may have to like implement CI, CD, monitoring, all these kinds of things. Okay. So when you get jobs, right, different companies also will have different levels of maturity. Sometimes you may get a job where you are the first DevOps person in the entire company. If the company does not know anything about DevOps, and you will be like the first guy who is going to teach them DevOps and cloud, stuff like that. And there might be other companies where like, you're joining like a 20+ member team, and they have full maturity. Companies like Google or Facebook, where they have continuous deployments, they have fully automated release pipelines for applications, and they deploy code to production multiple times in a day. So you don't know where you will get job and what would be the maturity level of the company that you are about to work. So these are different things, like different stages of maturity. Like, first thing is to have all of your company's applications code in one single location. You should be able to organize in an organized fashion, have in a single location in an organized fashion, have code for different applications in your company. Next is you need to have automated builds. Automated builds means like, somebody checks in code, the developer should get instant feedback about the new code, that whether the new code they checked in is good or bad. So that is continuous integration. Even before that, you need to have automated builds. Automated builds means like, you write new piece of code, you execute a command or a script, the code should automatically get compiled, and package should be created automatically. So that is automated builds. Once you have automated builds, you can mature into CI. CI means somebody checks in code, automatically a build should be triggered. That build is going to check if the new code that is checked in is good or bad. Okay, next you need to automate the deployment process of the new code, new builds into the dev QA stage environments of these applications. That is called as automated delivery. You push a button, code should be deployed to dev. You push a button, code should be deployed to QA. Push a button, production build should be deployed to production. So the process of achieving that is called as automated delivery. Once you achieve that, you can do continuous delivery to test, meaning that you automate the execution of all the various forms of testing for your application. And if your application is passing all the tests, it can be deployed to production safely. So like this, you can have different levels of maturity at different companies that you are going to work for. Understand?
Yeah.
Any doubts?
No.
I had one doubt. I mean,
Mm-hmm.
do we need like application level knowledge on this? I mean,
As a DevOps engineer, you do not need to have application level knowledge. Like what you need to have is knowledge of the tech stack, how to build your application code, what libraries your application is using, what are the dependencies of your application, who uses your application. So that kind of 10,000 feet view of what is inside your application, is needed. But you do not need to know why a specific class is declared in a specific way, or why a specific design pattern is used to implement your application. Those kinds of things and all you need not worry about.
okay.
Any other doubts, guys?
No, bro.
Okay, let's move.
Yeah,
So-
Krishna, one doubt here.
Mhm.
Yeah, so I mean, in addition to the previous question, you said in continuous integration, we test whether someone, whatever code they have written is working according to the functionality. So if we don't have to know the application level functionality, then how is this testing going to happen?
So we, as DevOps engineer, we do not need to worry about testing the code. So the QA team is going to write automated tests, like in Selenium or Cucumber, and the DevOps engineer is in the CI/CD pipeline that the DevOps engineer is creating for the application. He's going to include a step, and in that step, the execution of test cases or test suites by the QA team will happen.
Okay.
And a test report will be generated. And you can go and read the test report to assess the quality of the build. How many tests are passing, how many tests are failing, if all tests related to a specific functionality in the application is not working, that means the code is broken for that specific feature in that application. They need to create tickets, work on the tickets, fix the code related to that specific feature, and once the code is working as expected, the same tests that failed previously in the CI/CD pipeline will pass now. So our role is not like writing these test cases or test suites ourselves, but providing automation so that in a continuous fashion, we are able to assess the quality of the software builds.
Okay.
You understand?
Yeah. Thanks.
Hmm. Any other questions, guys? Okay. So the next topic. One more complex thing about DevOps is like, like if you take a Java developer, right? What is the one thing that the Java developer will know is Java programming. But look at the previous slide. I gave you a laundry list of tools that a DevOps engineer should have should have good capability on. So like, it's one of the challenges. Like, if you are a Java developer, you learn Java, you're good to go. But if you are a cloud engineer or a DevOps engineer, you need to learn how to use different tools, when to use which tool, stuff like that. But like, you do not need to be an expert in Python. You do not need to be an expert in Git. You do not need to be an expert in Jenkins. You do not need to be an expert in the cloud. But you need to know when to use cloud, how to use cloud, and you need to have broad overview, about the various tools and how these tools integrate with each other, talk to each other, and automate the release process of applications. That's one thing. One more aspect of software about career in DevOps is that, like based on the technology stack, the build, deployment, and DevOps tools that are available for an application is different. For example, you join a company like Microsoft. In Microsoft, all the software applications that are written will be using ASP.NET or C# or VB.NET kind of languages. They so the tools that are used to implement CI/CD for .NET applications, or the tools that are used to compile the .NET code and create a build, will be very, very different to the tools that are used to compile a Java application, build and deploy a Java application, stuff like that. So that means based on the company that you get your first job in, you are going to learn and use those specific tools that are relevant for the applications that are relevant for the technology stack of the company's applications. That is also important thing. That is one. It's not like, you can use Maven build tool irrespective of any language. You will use one build tool, you will use one deployment tool, you will use one CI/CD tool. It's not like that. One tool does not work for a different technology stack. One tool works very well for one technology stack, and it does not work that well for another technology stack. That is the problem in DevOps. It's in fact a good thing, because hundreds and thousands of people will get jobs because of this complexity. Okay, so that's one thing. So if you based on the company that you join, the tools that you are going to use for build and release and DevOps will be different. And the next set of slides is pretty much taking different examples and showing you that, how different things can be, that kind of a thing. For example, you get a job as a DevOps engineer at a company called as CardLife. CardLife company is using Subversion as a version control system, and all the code gets pushed by developers into Subversion. Each and every code check-in into Subversion will trigger a Jenkins build, and Jenkins is going to create the application artifact and upload to a software application called as Nexus. And they are using another software called as Rundeck that would take the build from Nexus and copy it to the various servers where this application should run and deploy the application. So if you get a job as a DevOps engineer at CardLife, these are the DevOps tools that you are going to use. Suppose you get a job as a DevOps engineer at Beck. So at Beck, what people are doing is all the applications that the company is writing is in Java programming language. The developers are writing Java code, converting the Java code into a build using the Maven build tool, and pushing the new application builds to Nexus. And the application, the runtime or the JVM for the application for these Java applications is Jetty. They're not using Tomcat, they're not using WebLogic, they're using Jetty. And the developers, like, they push and pull code into Git, and Git notifies whenever there is new code, it notifies Jenkins. Jenkins is in turn using Maven to compile and create the application builds and upload the builds to Nexus. And then from Nexus, the code gets deployed to the various servers that are running Jetty. So these are the tools that you will be working on when you get a job as a DevOps engineer at Beck. Okay, suppose you join a big company like Cisco as a DevOps engineer. Then you might be using different set of tools. All the developers in Cisco, they use the Eclipse IDE. And they're writing code. And the code that is written by the developers, they are checking into a code review tool called as Gerrit. So once the code is reviewed and the colleagues give a +1, the code gets merged into Git. And they are using Jenkins as the software tool to integrate all the code, create builds, and deploy to various servers. They are also using Maven and Nexus software tools to create and store the application builds. And they are also using a code quality tool called as SonarQube to measure the code coverage, test coverage, and the software quality of the code. Okay, so these are the tools. Mostly all the Cisco servers are mostly like Ubuntu and Windows servers. Suppose you get a job as a DevOps engineer in Adobe. Then these are the tools: Maven, GitHub. Adobe is using Chef recipes to configure all the servers and keep them in the desired state. They are using only Red Hat servers, and there are like a lot of applications in Ruby, and they're using Chef to configure and manage the application servers. Okay, if you take IBM is the DevOps process in IBM looks very different. So for all non-production deployments, they have one Blue Jenkins, and for production deployments, they have Red Jenkins. And the developers write code, they push the code to a version control system called as RTC. And RTC notifies Jenkins whenever new code is checked in. And, basically Jenkins triggers a build, it's going to run tests, it's going to make sure the application, all the tests are passing, the BVT, PVT, SVT, all these kinds of tests are passing. And if everything is passing, it's going to notify the Red Jenkins. The Red Jenkins is going to take the build created by Blue Jenkins, and it is going to deploy the product into hundreds of servers using the Chef software. So these are just examples. So what I'm trying to say is CI/CD process of applications will be very different for each company. CI/CD tools that are used to automate the release process of applications are very different based on the technology stack also. So like this, things can be like different. Okay. So like